Welcome everyone. Thanks for joining us. This is our fourth webinar on our ADS, our Automated Driving Systems for Rural America project. I am Christine Rogentine with the University of Iowa Driving Safety Research Institute. So our previous webinars are on our project website, which I'll put the link for that as well as the link for our data portal into the chat here in just a moment. A reminder, if anyone has any questions throughout, please just put them into the Q&A function and we will answer them at the end. So we'll go ahead and get started with Omar Ahmad, who's our Center's Deputy Director and the project manager for this project. So go ahead, Omar.
Thank you, Christine. Welcome, everyone. Thank you for joining us. As Christine mentioned, today's webinar is on the data portal. And so it'll be, during today's webinar, I'll give you a short overview of the project, and then we'll go into more details about the data that's being collected and how it's being stored into a database. And then most importantly, how you access it via the data portal. And then we'll have time at the end for your questions as well. So I'm going to start things off with a brief overview of the project. So this project is about looking at automated vehicles and testing them on rural roadways. And the reason why this is important is because a lot of the testing that's taken place up to now has been in urban locations and in interstates and in states that generally have warmer weather and don't necessarily have 4 seasons like we do in states like Iowa. And so it's really important that automated vehicles function on a variety of different types of roads, including rural roadways, because while a smaller segment of the population lives in rural areas, nearly half of the traffic fatalities that we have every year happen on rural roadways. Another really important component of this is looking at the populations that live in rural areas. And those populations have little or no access to public transportation. And as the U.S. Has an aging population, older folks are choosing to live in rural areas. But as they age, having the ability to remain mobile, to get from one location to another, from one rural location to another, or from a rural location to an urban location that has the regional services that they need, such as healthcare, it's so important to be able to do that. And automated vehicles can potentially be that amazing resource one day for people to remain mobile. And we would certainly like for that to happen in rural areas because it's very much needed. So this project is about looking at automated vehicles where they're able to navigate rural roadways well, and where they potentially have challenges, and then collecting data that can then be analyzed to help explain why. And that is the key component of this project. The key output of this project is to produce a very large, publicly accessible data set. And that's what we're going to be talking about today. So the vehicles that we're utilizing for this project is a Ford Transit. This vehicle is driven on a 47-mile route through 4 communities in Iowa. And this route has been specifically chosen to have as much diversity in terms of types of rural roadways as possible. So of course, we have a small interstate portion and rural highways, but we also have city streets with different types of intersections, and then roadways with different types of lane markings and no lane markings at all. And then additionally, gravel roadways. So these types of roadways are very common in rural areas. And so the route has those types of roadways, many different types of intersections. And then we've been driving this route for almost 2 years now in different weather conditions and at different times of the day. It's always driven, this vehicle is always driven by a safety driver and also monitored by a co-pilot. And then we recruit people to ride as passengers with us. So our data collection is organized into 6 phases. And as I mentioned, we started, well, almost 2 years ago. And initially, our vehicle was able to only drive under automation in very specific types of roadways, such as interstates and highways. But over that time period, we've upped the level of automation and the sophistication of the software. So now we're able to drive city streets, signalized intersections, and some controlled intersections. And then most recently, we've been driving on roadways that have no lane markings or gravel roadways. And we even have a few instances of some interaction between our vehicle and stop school buses, or vehicles anyway that are acting as cohorts for stop school buses. So we plan to finish our data collection very shortly here. The last phase of testing will begin in another week or 2 weeks, and then it's expected to go through the end of May. And by the end of May, we expect to have 80 complete drives, and all of this data is available and will be available on the data portal that we'll be talking about today. And so with that, I'm going to turn things over to my colleague, Cher Carney. Cher.
Thanks, Omar. So Omar showed you a slide that had the 47-mile route on it. And so we, for this project, have been collecting data along the entire route during each drive and across all of the phases. And by doing that, we're able to assess the expanding capabilities of the automation over the course of the entire project. Using this approach, we can also evaluate the performance of the automation compared to manual vehicle control for identical segments of the route. Analyzing the capabilities of the automation means understanding the performance of the many sensors that are on the vehicle. These include LiDAR, front and rear radars, a Mobileye collision avoidance system, as well as a Visalis sensor that collects environmental data. The data from the vehicle could be used to evaluate different things like where and how the sensors failed or provided degraded signals, how often sensor failure led to voluntary or forced takeovers, and how well the automation was able to perform if and when different signals were lost. The 2 images on the right show a visualization of some LiDAR data that we collected during one of our winter drives, and shows the degradation we saw due to ice buildup on the sensor. So we're also collecting video data from 4 synced video streams. All of them are recorded in high definition and time-stamped. We have video of the forward and the rear views, as well as of the safety driver and passengers. It's important to note here that the passenger and safety driver video is considered personal identifiable information, and so anyone who wants access to these videos would need to contact us through the data portal, and we can set up a data usage agreement. This slide shows an example of how important it is to have the video data in addition to just the sensor data. So on the upper left, you can see that the forward video stream shows a dust cloud from a vehicle that's a lot further ahead on the gravel road. And then the LiDAR is visualized in the screen below it. It shows an object ahead. You can see it's circled there, the red kind of blob. And then you can see the hard braking response of the transit in the upper right quadrant. So it's really the combination of these data sources that tells the complete picture. Without the video, you could maybe assume that there was an actual object ahead instead of just a cloud of dust that caused the hard braking response. In addition to the video data, we're also gathering feedback from the passengers as well as the safety driver. The passenger completes demographic survey as well as both a pre and post-drive questionnaire. We're interested in things like their initial perceptions of automation, trust and comfort, and then feedback about the completed drive. We also have the safety drivers report their comfort level during different specific portions of the route, like for example on the gravel, how they felt it behaved, or the merge onto the interstate. Each passenger, as well as the safety driver, wears an Empatica wristband, and we collect biometric data that has the potential to speak to their comfort and emotional state during the drive. We also ask each passenger to rate their level of anxiety on a scale of 0 to 10. They do this before the drive begins, and then again at 9 different locations along the route. This allows us to look at how their ratings change, not only by the amount of time that they spend in the shuttle, but by a specific location or a road type. And then lastly, the co-pilot not only functions as a second set of eyes for the safety driver, but they're also responsible for placing flags in the data. So flags are placed whenever vulnerable road users are encountered, and then the co-pilot records whether the vehicle was in automated or manual mode during those encounters. They also flag voluntary and forced takeovers. So voluntary takeovers are when perhaps automation isn't sophisticated enough to handle a particular situation. In phase 1, we took it out of automation in order to complete turns, which now in these later phases, it's doing on its own. It also occurs when the safety driver feels it's necessary in order to safely complete a maneuver, like some of the unprotected left turns that we have along our route. Forced takeovers occur when the automation disengages itself for unknown reasons, and the driver needs to retake control of the driving task. And then any safety critical events, near crashes or crashes, are also flagged by the co-pilot. And so with that, I am going to turn it over to my colleague, Steve Cable.
Thank you, Cher. So just to give a better idea of, Cher defined all of the different types of things that we're recording on a given drive. To give a little bit of more background, we've covered it in previous webinars, but it's worth stating here. After a lengthy evaluation period, we decided to use Baidu Apollo as the automation platform. It was chosen specifically because of its ability to deal with the different types of roads and situations that we were looking at tackling during the project. So Apollo being the main automation platform, it's also worth saying that we actually linked ROS, the robot operating system, on top of Apollo for a couple of reasons. First of all, ROS has existing driver architecture for some of the devices we are planning on using. So we want to leverage that as much as possible. The other reason is that ROS is pretty widely used across the industry for multiple automation platforms. So we wanted to make something that was digestible and usable by a wide population. This graphic that you're seeing here kind of gives a visualization of what a standard data set for a given drive's recording looks like. So kind of working from the top, the red that you see would be co-pilot markers. Below that, the light blue would be the main ROS and Apollo recordings, which include automation, health and performance, as well as the majority of the vehicle telemetry. Below that, the dark blue signifies the participant and research assistant logging. So that is all of the passengers' interactions with their devices that they were given for every drive, as well as the read-along research assistant. The light magenta under there is the Empatica recordings, so including both the baseline recording before the drive as well as the study recording during the drive. The small green places that you see there are indicative of the survey responses that the passengers would give. And then on the bottom, it would be the dark magenta kind of signifies the passenger video recording streams. So recordings of the passengers as well as the safety driver. So again, taking this all into account, you see a lot of different recordings going on at the same time. All of them are polling at different rates. All of them having a different lifetime in terms of when they start, when they stop recording. So it was imperative to kind of come up with a solution to really collate all of those different data sources and put them into a form that was able to be used by a researcher after the fact to kind of make sense of everything. So after each drive, all of those pieces of data are then worked through a replication system, which copied all of that data into a long-term cloud storage solution. During replication, each file basically is assigned a checksum value, which allows for validity kind of all the way through the process. We want to make sure that you could go back and check and make sure what you were seeing at the end is exactly what was created at the beginning. Once it moves its way to long-term storage, while this project was specifically taking a look at the collection and the dissemination of the data, we have developed a couple of scripts that we wanted to take a look at quick summary data from a given drive. So spitting out things like KML files, JSON, and XML. But the larger kind of process is taking all of those disparate pieces of data and being able to ingest them into a relational database. And so with that, I'll actually turn it over to my colleague, John Ryan, who will talk a little bit more about database design.
Great, thanks, Steve. Because there's a lot of data being collected from a variety of sources, such as the sensors on the vehicle, biometrics from the passengers, and survey data before, during, and after the drives, and because there's a need to join up all this data, we've borrowed some design from data warehousing and built a Snowflake data structure. So we utilize a fact table that sits in the middle and carries the foreign keys from each of the data entities so that at any point in time, you can access the related data. And because the data is captured at different frequencies and rates, the data is related by time based on the nearest timestamp. Now I'll pass it back to Steve.
Thank you, John. So now that we have all of the data, it's important to talk about what everyone came here today to talk about, the data portal. So the data portal is meant as a method for anybody to really come in and take a look at the data recorded from this project and to either get a summary of what's going on, or even to dig further into a specific phase or drive. So the data portal itself has kind of four main portions to it. I'll talk a little bit more at length about each portion, but giving an overview here, there's the data dictionary, there's the dashboard, there's the Drive Explorer, and there's the playground. The Drive Explorer and the playground are both functions that are available through registration. So I highly recommend signing up on the data portal so you can get kind of a more granular look at the data. The data dictionary itself is kind of the beating heart of all of the rest of the data. It defines all of the kind of key values that you'd be looking at if you were looking for a specific piece of data within the database or the individual recordings themselves. It defines everything through by topic. It is searchable by topic or by keywords, so you wouldn't necessarily have to know what topic you're coming in to take a look at. If you're looking for position, let's say, or latitude, you could simply put it into the search box and it would return back what topics deal with those sorts of information. The dashboard is what you see when you come as the landing page to the data portal. The dashboards show summary detail by either the top level at the project level, or by an individual phase, or even by individual drive. The data shown kind of includes automation performance, which shows things like miles driven, or miles driven under a specific under automation by federal functional code, or by road condition. It also maintains counts of safety critical events that might be seen along a given drive, or obstacles seen by the perception engine of Apollo. It also will count the number of vulnerable road users noted by the co-pilots, and as well as the number of V2V encounters along a drive. The Drive Explorer is another portion as you drill down into an individual drive, and the hope is that it would give you a quick searchable kind of annotated timeline to help somebody truly explore a drive second by second. So it will show points of interest, including all of the co-pilot markers, and as well as a listing of the disengagements for a given drive. And then also allows a viewer to play back video of any moment along a given drive. So you can scrub to either a specific second, or you can jump to a marker and then play back video and some limited telemetry data to kind of get a better handle on what's happening during a given drive, kind of taken it in association with the markers and other data recorded. And then finally, there's the playground. The playground gives a user the opportunity to get to get kind of a more granular sense of information at a project, a phase, and a drive level. So it's split up into two general areas. The first, it being the common queries. The common queries are something that is a predefined set of questions that we kind of anticipate people wanting to take a look at. And it gives somebody the ability to search for something without necessarily having to dig through the data dictionary to find individual piece of data to pull out. Like, we wanted to give somebody an easy way to access some of the more pertinent data. The other side is the custom query. The custom query is kind of the power user part of the playground. This gives gives a user the ability to search for a given piece of telemetry or rider information using other pieces of vehicle or rider or temporal information as criteria for that search. And I'll pass it back to John, who will give a little bit of background about how some of those queries are formed.
Sure, thanks again, Steve. So I'm going to talk about a couple of examples that are available in the common queries, and talk about how the data is kind of put together to output the data. So the first example is the number of takeovers by road classification. And the data is collected and organized by drive, which rolls up to phase, and the phases roll up into all drives. And then we have the takeovers, which comes from the chassis data and includes the drive mode by drive and timestamp. And in this data, we need to determine when the drive mode changed for particular value pairs. A change in drive mode from a code of 1 to 4 means a takeover by steering, braking, and accelerating. And then a change in drive mode from 1 to 0 means takeover by button. And then we have the location data, which comes from the best pose data and includes the drive, the latitude and longitude, and also a timestamp. And then finally, we join to the road classification data, which is geofenced. When the best pose Latin long data falls within the geofence boundary, it is classified with the corresponding road type. And then we join these elements together to produce the table you can see in the slide. And then the second query is an example of the average anxiety rating by driving mode and environmental condition. So again, the data is collected and organized by drive, and the anxiety data comes from the participant survey data and collected at particular points throughout the drive. It's comprised of rating values on a continuum from 0, which represents the lowest level of anxiety, to 10, which is the highest. We again join to the best post data to get the location at that time. And then we make a call out to the Open Weather API to get, or using the timestamp and latitude and longitude to get the weather for that particular event. Those data elements are joined together to summarize by manual versus automated drive mode. And then within each of those, by the weather conditions, such as clear sky, light snow, moderate rain, etc. And then the anxiety ratings are averaged by phase or drive, which the user can select from the controls on the page. And now I'll pass it back to Steve.
Thank you, John. Omar, would you mind dropping share for a second? So kind of to pull everything together, what I'd like to do is kind of give a general use case of how one might interact with the data portal in order to get at a piece of information that they're specifically interested in. So here, as you can see, I'm logged in at the data portal, and I'm seeing the summary data for the entire project as things said as we gear up for phase 6 data collection. So how one might use this if we were particularly interested in performance or kind of information during a specific event. Let's say we were curious about how things worked during rain. So each individual weather type is calculated for all drives, and we can click on rain here to see all of the drives that have included rain during the drive. Here it shows all of the drives. If we click down further into a specific drive, we come up with drive 9 here. For drive 9, we can see, again, all of the same kind of summary information that we saw at the total level, but it gets more granular when it starts taking a look at the actual drive route. You can see the automation levels during the drive. You can see all of the co-pilot markers. You can also see things like the weather events during the drive. You can see the wind speed, air temperature, road temperature, all sorts of the information that I kind of talked about before. If we wanted to go deeper, we can go into the Drive Explorer for that drive. And this will, again, give us a kind of timeline of the given drive. So here we know that we see that this drive started at the Kelowna Public Library, but we can actually skip around anywhere arbitrarily within the drive. Or if we wanted to, we can search by the Copilot markers. So if we pull up the list of Copilot markers, let's say we're very interested in, we already have defined that we're looking at a rainy drive. If we're looking at the interactions between automation and other vulnerable road users, here we can see that there's a horse and buggy at marker 3. So as we kind of zoom into that, we can click on the marker and we can see a thumbnail of the forward view of the vehicle at that point in time. Beyond that, we can expand the drive detail down here. We can see at that marker, we can see the speed, the throttle level, braking level, steering position, as well as some information about the road surface. And then finally, if we wanted to take a look at video from that event, we can click on this button here, and it will play back the 10 seconds before a given time point. So we can see here, we can see this horse and buggy rolling up and see it in the rear view as we roll by it. Again, this is to go kind of further, you can also take a look at the satellite view of a given area. I know that all of us have a very good understanding of what the area looks like on the route. But for those of you who may not be familiar with the rural Iowa areas that we drive through, you can zoom in on a given place and see kind of what the environment around that given flag looks like. So again, we can search by marker, we can search by different engagements, different disengagements. We can take a look at the general view or general information about the drive. But again, all of this is meant to give somebody a better idea of something that they might want to look further at. Maybe the information that's given here in the Drive Explorer isn't as detailed as the actual, it's at a much lower polling rate than what the actual recording is. So maybe you wanted to, now that you've identified something within Drive Explorer, maybe you wanted to come back over into the playground, and we'll just take a look at setting a custom query for that drive. We can take a look at, let's say we wanted to know what the specific state of wetness on the road was at the time. So we can go down and look for the individual, using a data dictionary, we can look for the individual piece of index data that we're looking for. We can add it as our data selection. Let's say that we're looking at it only when the vehicle was in automation. So again, we can, using the drive dictionary, the data dictionary, know that we're looking for things where the chassis drive mode equals 1, add that as a filter. And then finally submit that data, and it will come back with a list of the queried for data basically at those given points in time. And so again, what we're kind of showing here is that a lot of this data, we're trying to make it as easily accessible as possible. But we also know that while creating the data portal, there are lots of situations where somebody may want access even further. Maybe they want to take a look at the source data itself. All of that information is accessible. The source data is available. If you get in contact with us, we can set you up with a way to get at the source data itself. But otherwise, the idea again is to create something that is accessible to a wide range of people, and gives them an idea of being able to tackle what is in reality a very large amount of data, and making it as quickly and as openly accessible as possible. So again, kind of to wrap things up from my end, I do want to highly recommend that everyone who is interested, everyone who's in attendance today, please do drop by the data portal, sign up, and let us know what you think. And if there are things that we can do to improve it, we are in a constant state of improvement as we go along. So with that, I will turn it back to Christine for final thoughts.
Yep. Okay. Thanks to all of our presenters. So we'll start with some questions now. We'll start with a question we got in from the registration. Do you have any plans or thoughts about keeping the shuttle in service after the project completes, or do you have any sequel plans identified?
So we don't have anything immediately lined up after the project ends. That's not to say that the vehicle itself isn't available or ready to work after the project ends. It's still very much viable and will continue to be viable to work as long as the HD maps, the road systems don't change. It's still able to be driven. And there are lots of ideas about things that could happen, but it depends upon just choosing what way to go from there.
Okay. Another question that we got in, when do the quarries in the when you do the quarries in the playground, can you get access to the underlying video or ROSBAG files? For example, all of the video data and ROSBAG files within 30 seconds of a VRU marker, more than just thumbnail that you demonstrated.
The short answer to that is no. ROSBAG files kind of being what they are, they're a little bit hard to skip around in and to kind of scrub. Those files are available, and you could very well take the information that you get by using Drive Explorer, by using the playground, and you can use that to further dig into that ROSBAG file data. But it's really the idea is that because it is a format that is kind of widely used, there are a lot of tools that are out there that the existing tools that would give somebody the ability to kind of tailor what they're looking for a little bit better than reinventing the wheel for this project.
Okay. Do you have any plans to update the HD map, or how to update the HD map?
We have been looking into the possibility of creating. So for this project, we've been utilizing that. We've had a partner in Manley Communications that has done an excellent job at helping us refine the map as the project has continued, because that's one of the kind of main takeaways that we've seen is that especially for the platform that we're using, the HD map and tweaking, making small alterations in the HD map come up again and again. And so for this project, we've been working very closely with Manley, and they've been excellent in making those small granular tweaks to the map as we go along. Going forward, we have had some internal discussions about how we manage the map, or if we create new maps. And there are certain functionalities out there that we can definitely do that. And I think that is something that we are actively kind of engaged in exploring those options. But from a project perspective, we probably won't be updating the map much after this next phase basically starts.
Yeah, and if I can just add something onto that, as Steve just kind of touched upon there, the map does serve a really important component, more important perhaps than we initially thought it would be, in terms of enabling the automation to work well in specific areas. So they're local considerations for specific roadways and specific intersections that are not that where the automation needs some guidance from the map, on additional guidance from the map on what to do. And actually, this will be one of the key topics of a session that we will organize at the upcoming arts conference on during the week of July 9th in San Francisco. So if you're planning to attend the arts conference, please consider attending our session, because we will be talking about this in more detail at that session. And our technology partners will be at that session as well. So I think you'll get a good perspective on things.
Okay, is there a term in the data dictionary that allows us to focus solely on sections of the drive where the vehicle is traveling on unpaved roads?
Not specifically in the data dictionary. There's nothing that defines gravel roads. You could use, for the most part, in even our kind of creating summary data, we're creating specific geofenced areas around areas of roads. So the gravel road has its own section. The unpaved section has its own geofence. And that's something that we'd absolutely be willing to share. And what you could do then is search using those geofenced areas as a marker to find that data. but there's nothing in terms of like an enum or something like that in the dictionary that defines road types.
Okay. We had a couple other questions that we had typed answers to, but just so everyone can see those, how long will the data be available to the public?
Omar, do you want to? I'm happy to.
Yep. I'm here. Sorry, it just takes me a moment to unmute. I have too many windows open. The data will be available to the public for a duration of 5 years. It's available now, but the project will end this year, and after its end, the data will still be available for 5 years.
Okay, and then I'm wondering if you observed any pattern when the drive was taken over by the safety driver.
Yeah, I think I tried to get at hopefully what was the spirit of the person who asked that question. So I think takeovers is something that happens quite a bit. And so as we progress from one phase of the data collection to another, the percentage of the drive that's being done under automation has steadily increased. And I think in the most recent phase, we might have been as high as 95% or above under certain drives. But the number of takeovers, that is that when the safety driver decides that they want to resume takeover manual control of the vehicle for one reason or another, that the number of takeovers has remained steady through each phase. It's just that the reason for the takeovers has changed. And so some of the initial reasons for why we took control from the vehicle in the early phases no longer is needed, but now there are new reasons, because as the vehicle is exhibiting automation behavior in more complicated situations, now there's yet more reasons to potentially, in certain situations where the safety driver wants to take over. And I hope that kind of answers that question. And I know that we're planning to, in the very near future, either make a poster presentation or write a paper about this specific topic, because I think it's a very important one.
And
Okay.
I was just going to add, if I can, that that there is a way to go in and look for every drive at the number of disengagements that were either voluntary or forced. And so you can get an idea of when it was taken over. I think that you would see that that for many of the unprotected left turns, it's taken out almost always. There are occasions where we come to that intersection when there's not as much traffic and the vehicle is able to handle it, but there are some patterns. And so if you were interested in that, I think you could find that data, and as Steve showed, you can pull up the video that's associated with that that takeover and watch that as well. So hopefully that helps.
Okay. Next question, is the underlying HD map part of the database that can be accessed?
So the underlying HD map is not part of the database that can be accessed, excuse me. But the technology provider that made the HD map, Manley Communications, I think it is going to be possible to reach out to them if your specific needs require that you have, I don't know, a deeper level access to the HD map. That technology provider express a willingness to potentially share it. I think that's going to require, specific targeted communication with them to come up with the method for doing that.
Okay, for gravel and unpaved road, did the vehicle use the HD map, and did your study find the use of HD map useful in lower class roadways?
Go ahead, Steve. Yeah.
Yes, we did for both the gravel and unpaved roads. Both of them relied on the HD map in order for everything to work properly. There are lessons learned as we came away from it, though, of specifically taking a look at how somebody drives those given roads. So taking a look at gravel roads specifically, the automation software really wants to define given lanes on a given roadway. But in reality, if somebody is driving a gravel road, they may find themselves driving more and in the center of the road until they come to a passing vehicle or something coming down the road at them, at which point they'll kind of drift more towards the sides of the road, people pass, and then both cars more or less move their way back towards the center. That wasn't necessarily a behavior that Apollo specifically dealt with or had an existing way of dealing with. So we did have to make alterations inside the HD map, again, to shift some of these virtual lanes inside the HD map over so that the vehicle would drive closer to the crown of a gravel roadway, so that it wasn't edges of gravel roadways tend to be really loose and be very slippery. So getting it to be able to travel closer to the center, but also to be able to kind of deflect out from the center when they come to a oncoming car was really a necessity as well. So again, as we kind of said over and over again, the HD map did play a very instrumental role in how, not only how the vehicle traveled on city streets or on highways, but also on those unpaved and unmarked roadways.
Gotten in so far. So unless anyone has any last minute questions that pop up while we're wrapping up, we'll go ahead and wrap up here. So thanks for everyone again for calling in and for all your questions. There will be a recording of this available on our website if you want to share it with any of your colleagues. And if you think of any other questions that you have, especially as you're digging into the data portal, please contact us. Our contact information is on the website. And we will have one more webinar later this summer, a kind of a wrap up. But if there's anything specific that you'd like us to cover in that webinar about this project, please let me know. So thanks everyone, and have a great rest of your day. Bye.